Yes, welcome once again to Maths with EJD. In this video, my focus is on matrix inversion by the minors and cofactors method. Like I said in the last video, there are different methods for finding inverses for matrices. So this is the first in the series of matrix inversion. Of course, the other ones may not follow this video in particular order because there are some things we have to deal with before we take the other method. So as the time is ripe, you will see matrix inversion by Gauss-Jordan method. That is talking about elementary row operation. There's matrix inversion by solving systems of linear equations. I'm probably Kelly Hamilton. I'm trying to figure that out along the line. So let's focus. Let's go to what we have for today. Matrix inversion by the minors and cofactors method. All right. So in this case, the overall thing you need to understand is that if we have a matrix A, the inverse of that matrix is given as A inverse. And using the minors and cofactors method, you know that at the end of the day, the inverse of A is the same is equal to the inverse of A is equal to the adjoint of A over the determinant of A. Now, as we go on, you'll find out what adjoint, and of course, you already know what determinants are. We already treated that under matrix properties. Okay, so you see, to do matrix inversion by minors and cofactors method, you need to first of all find the determinant. Then you find the matrix of the minors of the of matrix A or any matrix you're given. Then you now find the matrix of the cofactors, and then you find the adjoint, which is the transpose of the cofactors, and then finally you divide the adjoint of the matrix by the determinant, and then you get your inverse. Okay, let's go on to look at that. Just like I explained to you, to find the to find matrix inversion or the inverse of a matrix using the minors and cofactors method, given a matrix A, given a matrix A like that, this matrix a 2 by 2 matrix, that is, you have A11, A12, A21, A22, and you are required to find A inverse, which I already told you is equal to the adjoint of A divided by the determinant of A. Now, it is important to know that no determinant, no inverse. In the next video, I think I'm going to talk about special matrices. Special part of the special matrices will be things like singular and non-singular matrices. So singular matrices are matrices whose determinants are zero. And for singular matrices, since you cannot get the determinants, you can also find their inverses. So when we get there, I'll talk more about that. Okay, so no determinant, no inverse. That's a very key thing. So you can only find the inverse of a matrix who has a determinant, that has a determinant, right? So, of course, like I told you before, from that matrix now, the first thing you want to do is to find the determinant of the matrix. And you already know how to find determinant from that last video. To find the determinant, so of course you have these two straight bars on the matrix, and then that's simply A11 multiplied by A22 minus A12 multiplied by A21. So this is the determinant of this matrix. This is the oh, let me do this bet. Okay, I don't want to cover any number. Okay, more like this. So that's the determinant of this matrix, A11, A12, A21, A22. So now that you find the determinant, the next thing you want to do is to find the matrix of minors, the matrix of minors. And how you find the matrix of minors is very close to what you do when you are looking for the determinant of a 3 by 3 matrix. So to find the matrix of minors, so the idea is that each element of of your matrix has a minor. And the way to find the minor is to cover the row and the column to which, for instance, to find the minor of A11, so you cover the row to which it belongs and the column to which it belongs, and whatever is left, that is A22. So that A22 comes over here and takes the place of, and occupies the place of A11. So you can say A22 is the minor of A11. Okay? Now, if you don't get that, I'm going to do the same for A12. So what is the minor of A12? You get the minor of A12 by covering the row to which it belongs and the column to which it belongs. Whatever is left, which is A21, is the minor of A12. So A21 is the minor of A12. Then, now that that is done, the next thing is you want to find the minor of A21. So this is A21. To find the minor, cross the row, cross the column. What do you have left? A12. So A12 takes the place of A21, and that's why you have this here, right? And then we have A22 to go. You need to find the minor of A22. This is A22. Cross the row to which it belongs and the column to which it belongs. What you have left is A11. That is why A11 takes the place of A22. The position A22 occupies, A11 takes that. So by the time you're done doing all that, then you can say that this is the matrix of the minors of A. So now you have A22, A21, A12, A11. That is the matrix of the minors of A. Now, once that is settled, you have the matrix of the minors of A. The next thing you want to do is to find the matrix of cofactors. Now you see that starting from the second step, everything is linked. If you don't get the minors correctly, you won't get the cofactors right, because the cofactors, you get the cofactors by simply applying the signs, by simply applying the signs of the matrices. For instance, I told you the other time that okay, let me uh remove this. Okay. Okay. Now, I told you about how to get the sign of a matrix the other time. This, of course, this is A22, right? But it is occupying row 1, column 1. 1 plus 1 is 2. So, and then you say minus 1 raised to power 2. So, you end up getting positive, that's plus 1. So, that means the sign attached to this is plus. Now, don't get confused about the 2, 2, and 2, 1. We actually got that from, normally, this is what we should have been dealing with the matrix A. But now we are concerned with the position, the row position and the column position. Never mind that A to 2 has been moved there, right? It was because of the operation we did, right? So row 1, column 1, you have positive, and then for 2, 1, so you have minus 1 raised to power 2 plus 1, that's 3. So this will end up being minus 1. That's why the sign attached to this is minus. Is minus. And of course, like I told you, you don't always have to worry about this. You don't always have to worry about this. All you just need to do is know that the element in the first row, first column is simply this, has a plus attached to it. So, and once you have that plus fixed, going to the right, the next one will be minus. If there's something else to be plus, to keep alternating. Going down also, it keeps alternating. So this is minus and this is plus again. So you don't have to cram anything. Just know that the element in the first row and first column is carries a positive sign, and keep alternating the signs to the right or down across the row or down the column. Yeah. Okay, so now that you have got the signs, now all you just need to do, so you find the matrix of the cofactors, and to find the matrix of the cofactors, so what I call cof A will just be, so everything you've had here. Okay. Did I delete something there? Okay, yeah, 8 to 2. So everything you've had there, right? You just apply the necessary signs. So what you have for the first one is plus. So that is why this one is just 8 to 2. Then for 8 to 1, the sign attached is minus. That's why this becomes minus 8 to 1. Then for A12, the sign attached is minus. So you have minus A12. For A11, the sign attached is positive. That's why this is just A11 because it is positive. So now that is the sign, that is the cofactor of A, right? Because you just apply the signs. Okay, now that you have applied the signs, the next thing is you find the adjoint of matrix of cofactors. So, and to find the adjoint, it's very simple. The adjoint of A now will be the transpose. So this matrix now, you transpose it. So the adjoint of A is the cofactor of A transposed. And in the last video, I explained to you how to find the transpose. Just change the rows to columns, that's all. So here, row 1 is A22 minus A21. So that becomes the first column, A22 minus A21. So row 2 is minus A12 A11. Then that becomes minus A12 A11. So by doing that, you simply get the adjoint of matrix A. So this is the adjoint now. And once you get the adjoint, don't forget the formula. It is the adjoint of the inverse of A is the adjoint of A divided by the determinant of A. So now the final thing is to find the inverse of A. So define the inverse of A. So you have A inverse equals inv A, if you like. That is equal to adjoint of A over determinant of A. The A itself, right, is the A itself is I mean the adjoint of A is A22 minus A12 minus A21, A11. That's what you have up there. And all that divided by the determinant A11, A22 minus A12, A21. Of course, usually you might have to, express it like this. So since you are dividing by that, so you can simply say it is 1 over A11, A11, A22 minus A12, A21. So all that into the matrix, into the adjoint, right? So that's A22 minus A12, then minus A21, then A11, like that. You can simplify it that way if you like. So now that you have got the rules, okay, I mean, don't just to run over it. So if you're looking for the inverse of a matrix using the minors and cofactors method, the first thing you may want to do, of course, you can also do this last because it doesn't have the determinant does not depend on any of the steps you've taken. The determinant stands on its own, so you can find it first or you can find it last, anyhow you like. But then the other ones have to go sequentially. So the matrix of minors, you get the matrix of minors by covering each element in turn, and whatever is left, that will be the minor. Okay. Of course, when we get to 3 by 3 matrix, it's a bit different, but it's nothing beyond what you can understand, right? Then after finding the minors, the next thing is you apply the relevant signs to each element and you get the cofactor. And then after you get the cofactor, you transpose the cofactor and you get the adjoint. And once you have your adjoint and your determinant, then you can easily evaluate your inverse. The inverse is simply the adjoint over the determinant, and that goes. So let's look at some actual examples. So of course, like you already know, you can only find the inverse of a square matrix, 2 by 2, 3 by 3, 4 by 4, and so on. You can only find the inverse of a square matrix. And for a rectangular matrix, where the number of rows is not equal to the number of columns, you cannot find their inverse, okay? So let's deal with this 2 by 2 matrix. You want to find the inverse of P, which is 2, 3 minus 1, 4. 2, 3 minus 1, 4. How do you find the inverse of this? Using the minors and cofactors method. So the first thing, like I said, of course, it can also be the last, is to find the determinant. For a 2 by 2 matrix, the determinant is pretty straightforward. So you just have 2 times 4, 8, minus, what is happening here is you have 2 times 4. Okay. So that's 2 times 4 minus 3 times minus 1. That's 8 minus 3, and that is 8 plus 3, which is 11. That is why we have this 11 here. So that's how you get the determinant of P. Okay, now that that is settled, the next thing you want to do is you want to find the minors of P. And how do you find the minors of P? Don't forget, you cover those things in turns. Let's say to find the minor of 2, 2 is the first element, cross the row to which it belongs and the column to which it belongs. 4 is left, so 4 takes its place in the minors. And then now that that is settled, the next thing is to find the minor of 3. To find the minor of 3, cross the row to which 3 belongs, cross the column to which it belongs, and then you have minus 1 left. So minus 1 is taken here. Okay, so next you need the minor of minus 1. So minus 1, cross the row, cross the column, 3 is left. So 3 comes here. So that is the minor of minus 1. And lastly, you need the minor of 4. So for 4, cross the row, cross the column, 2 is left. So that's why 2 is transferred here. So that way you find the minors, the matrix of the minors. So the minors of P will be 4 minus 1, 3, 2. So the next thing is to apply the signs, right? You want to apply the signs. Of course, to apply the signs, you know that naturally for the first element, the sign attached is plus. Of course, this will be minus, this will be minus, and then this will be plus. So plus minus, plus minus, minus plus, like that. So now that you know those are the signs, so the next thing is to get the cofactors of P now. So since plus is attached to 4, so you have plus 4, then minus, you know, there was minus 1 before, so minus at again, so you have minus minus 1. Then for 3, you have minus 3, and then plus 2. And then all of that simplified, you have 4, 1, minus 3, and 2. So those are the cofactors of P. So having found the cofactors of P, then you find the adjoint of P. The adjoint of P is simply the transpose of the cofactor. So this cofactor, now you just transpose it and you get the adjoint of P. So, and transposing that simply means change, first row becomes first column, second row becomes second column. So 4, 1 becomes this, then 3, 2, then 3, 2, this row becomes this. So that way you have transposed the matrix. And now once you do the transpose, the next thing is just to find the inverse. So the inverse of P, which is also P inverse, is the adjoint of P over determinant of P. So the adjoint is 4 minus 3, 1, 2, and that's what you have here. The determinant is 11. That's what you have down here. So you can say you have 1 over 11 into 4 minus 3, 1, 2. So if you like, you can put the 11 inside. So you have 4 divided by 11 minus 3 divided by 11, 1 divided by 11, and 2 divided by 11. And that's why you have the inverse of that's why you have the inverse of the matrix P. Of course, how do you know that your inverse is correct? Um, to check if your inverse is correct, all you just need to do is to multiply the original matrix P and the inverse of P. If you do that, the multiplication, the answer must be equal to the unit matrix. Of course, the unit matrix, if you remember when we talked about types of matrices, unit matrix for a 2 by 2 matrix is 1, 0, 0, 1. So you already know how to multiply matrices. So for you to know if your determinant is correct, you can just do, so all you just need to do is to multiply 2, 3, minus 1, 4, and 4 over 11, minus 3 over 11, 1 over 11, and 2 over 11. You know, when you multiply this, you should be able to get the unit matrix. If you don't get the unit matrix, then something is wrong with your inverse. So that's how to check. Interestingly, you know, since we already agreed that matrix inverse is not commutative. So, but interestingly, P inverse should be is the same thing as P inverse P. So anyone that comes first, you must always get the unit matrix. So you can check. So anytime you find an inverse and you don't have any other means of checking, so the best thing is multiply the original matrix by the inverse, and you must get the unit matrix. So, okay. Now that that is settled, let's take a more complicated one, not so difficult to comprehend, but it's 3 by 3, so that's why it may be a bit more, it may take a bit more focus. Okay. Now, we want to find the inverse of Q, 230 minus 145, 221. Again, like I advised, you can find the determinant first or last because it has nothing to do with the other things in between. So the determinant of Q, you have those in straight bars, 230, blah, blah. So, and you already know that, of course, this is plus, minus, plus. So you take plus 2, you cross the column, cross the row, and you have 4, 5, 2, 1. That's why you have 4, 5, 2, 1 here. Okay. And again, you take minus 3, you know, minus and 3 together. So that's why you have this minus 3 here. And since that is taken care of, so you cross the column to which 3 belongs, and you cross the row to which it belongs. So what do you have left? Minus 1, 5, 2, 1. That is why you have minus 1, 5, 2, 1 here. Okay. Uh, so since that is taken care of, then you have 0. So 0 it goes with plus. Whether it's plus or minus, it doesn't even matter. Zero will make whatever you have in the whatever else you have zero, right? So, but of course, for the sake of it, so you have zero here, and that's why you have this plus zero. So cross the row to which zero belongs and the column to which it belongs. So you have minus 1422. That's why you have this minus 1422 right here. Okay. So having settled that, you have plus 2 is 2 here. This 2 comes here. And then here I went straight because by now you're used to doing this. 4 times 1 is 4. Here 4 times 1 is 4 minus 5 times 2, that's 10. So 4 minus 10 is the minus 6 you have here. All right. Then you move to the next one. Minus 3, this minus 3 is what you have here. And then minus 1 times 1 is minus 1. Minus 5 times 2, that's 10. So minus 1 times minus 10, minus 1 minus 10 rather, minus 1 minus 10 is minus 11. That means let's assume you're owing 1 and you're also owing 10. That means you're owing 11. So I know people get confused with things like this, right? What you don't know when to multiply or add. So minus 1 minus 10 means you're owing 1 and you're owing 10. That means you're owing 11. But minus 1 times minus 10 is totally different from this. Minus 1 times minus 10 with minus times minus plus 1 times 10, 10. So if there's no multiplication, just assume that it's the owing idea, okay? So don't get confused over that. All right. So, of course, again, minus 1 minus 10 means you're owing 1, you're owing 10, you have minus 11. Or you can have minus 1 times minus 10, which can also be written as minus 1 multiplied by minus 10. This is also multiplication. That means minus and minus plus 1 times 10, 10. So get that straight so you don't get confused. So then, having taken care of that, of course, if you're in an exam situation, you don't have to worry about the last one because you already know zero will multiply this and everything goes to zero. So normally you don't have to worry, but we are not under pressure here right now. So let's do it. So you have zero. This zero is what you have here. So minus 1 times 2, that's minus 1 times 2 is minus 2. Then minus 4 times 2, that's 8. So minus 2 minus 8, you have minus 10. Mind you, it is different from minus 2 times minus 8. Minus 2 times minus 8 would have been minus and minus plus 2 times, sorry, this is 8. 2 times 8 is 16. So, but this is minus 2 minus 8. So you owe 2, you also owe 8. It means you're owing 10 altogether. Okay, so of course, if you had minus 2 plus 8, that means you owe 2, but you have 8. If you pay the 2, you have 6 left. So that you have means plus. But if you owe, if you have 2 and you owe 8, if you pay the 2, you still are owing 6. So that's how to master all that. Okay. So now that that is settled, minus 2 minus 8 is minus 10. So that means you can have 0 multiplied by minus 10. So you have 2 times minus 6, that's minus 12. Minus 3 minus 11, that's plus 33. 0 times minus 10, that's 0. And then you have 33 minus 12, or minus 12 plus. So you are owing minus 12. You're owing 12 rather, and you have 33. If you pay the 12, you have 21 left. So this 21 now is the determinant of matrix Q. Now, the next thing is to find the matrix of the minors of Q, which I call mean minus Q. Now, because it is a 3 by 3 matrix, things are a bit trickier here, but not something you cannot handle. So, to find the minors there, in the case of 2 by 2, just cover and whatever is left, you write it up. But here, to find the minors of 2, to find the minor of 2, rather, to find the minor of 2, you cross out the column, cross out the row. All you have left is 4, 5, 2, 1. That's why you have 4, 5, 2, 1 here, Then, to find the minor of 3, cross the row, cross the column, you have minus 1, 2, 5, 1. That's why you have minus 1, 2, 5, 1 here. Okay. To find the minor of 0, you cross the column, you cross the row, you have minus 1, 4, 2, 2. That's why you have this minus 1, 4, 2, 2. So the sad part here is that, in the case of determinant, right, you just need one row. But here, in looking for minors, you have to do it for each element. Even if there are 16, you have to find all the 16 minors. So here, to find the minor of minus 1, cross out the column to which it belongs and the row to which it belongs. And you have 3021. That's why you have this 3021, you know. And then for 4, to find the minus of 4, cross the row, cross the column. You have 2021. That's why you have this. All right. And then to find the minor of 5, cross the column, cross the row, and you have 2322. So that's why you have this. Okay. And then to find the minor of this first two, cross the row, cross the column, you have 3045, which you have here, 3045. Then to find the minor of this other two, cross the row, cross the column, you have 2 minus 105. That's what you have here. Okay. Then the last one, the number 1, to find the minor of 1, cross the row, cross the column. You have 2, 3 minus 1, 4, 2, 3 minus 1, 4, this way. Okay. I mean, that can be really tricky. If you're under tension, you can easily get this wrong. Now, one thing with matrices is that they are very simple if you know what to do. But if you're not careful, you can actually, if you can mess up a sign or mess up a number and everything just goes awry. So you have to be, yeah, you need to learn patient haste in an exam situation. All right. So now now that you have got all these things, the next thing you want to do is to now, you can also already see that the bars represent determinant, right? So so you're looking for the determinant of those things. So 4 times 1 is 4 minus 10. You have minus 6, minus 1 times 1, that's minus 1 minus 10, minus 11. Minus 1 times 2, that's minus 2 minus 8, minus 10. Okay. And then we have the next one, the determinant of 3021. 3 times 1, 3, minus 2 times 0, 0. So that's why you have this 3 here. Then 2021, 2 times 1, 2 minus 0 again. This is 2. And then 2322, that's 2 times 2, 4 minus 6. That's why this is minus 2. And then the last row, you have 3 times 5, 15 minus 0. That's why this is 15. 15 minus 0 is 15. 2 times 5, 10 minus 0. That is why this is 10. 2 times 4 is 8. Now, 8 minus 3 times minus 1, that's another minus 3. So that's 8 plus 3, and that's why this is 11. So with that, you have tidied up the minors of Q. So this matrix here gives you the matrix of the minors of Q. So now that that is taken care of, the next thing is to find the cofactors. And like I said, to find the cofactors, all you just need to do is to apply the signs. Apply the signs. And how do you apply the signs? You know, the first one is plus, the second is minus, plus. Then since this first one here is plus, going down, you also have minus, plus. Then second row, minus, plus, minus. Then third row, plus, minus, plus. So just apply those signs here and you get the cofactors. So plus minus is minus 6. Minus minus, that's plus 11. Plus minus is minus 10. Minus 3, then plus 2. Then minus minus 2, that's why you have 2. Plus 15, that's 15. Minus 10, that's why you have this minus 10. Plus 11, that's why you have this 11. And by applying the signs, you have your cofactors of Q. And since that is settled, the next thing to do is to find, I would think that the hardest part when you are dealing with 3 by 3 matrix is to find the minors, because that is really tricky. So now that you have the cofactors, then you get the adjoint of Q. And how do you get the adjoint of Q? It is actually the transpose of the cofactors of Q. So transpose means the first column, minus 6 minus 3, 15, becomes the first row in the transpose, right? Then the second column, 11 minus 2, 11, 2 minus 10 rather, becomes 11, 2 minus 10 as a row in the cofactor, in the adjoint, sorry. The minus 10, minus 10, 2, minus 10, 2, 11, which is the third column, becomes the third row in the transpose. That's minus 10 to 11, now as a row. So once that is well done, so you can say this is the adjoint of Q. Since you have the adjoint and you have the determinant, the rest is simple. You just need to now say this. So Q inverse is equal to adjoint of Q over determinant of Q. That's like the whole the adjoint divided by 21, which is the same thing as 1 over 21 times that. Of course, you can simplify this if you like. So if you want to try to simplify that, you can simply do this. You just have Q inverse equals, so if you put 21 inside, that's minus 6 over 21. That's minus 2 over, 3 divides that. That's minus 2 over 7, I believe. Yeah. So 3 in 6, 2, 3 in 7, 3 in 21, 7. Then the next one is minus 1 over 7. Then you have 15 over 21. That's 3 goes. That's 5 over 7. Then next you have 11 over 21. So, since nothing cuts that, then you have 2 over 21. Then you have minus 10 over 21. Then next you have minus 10 over 21 again, 2 over 21, and 11 over 21, like that. So you can do that, or you can just simply leave it this way. It's not compulsory to do all, to go all that way. So that's a choice for you to make. But of course, if you're answering like a multi-choice question, the way the answers are presented will determine whether you leave it in the initial way or go through the stress of dividing through by 21. So, but just know that those are possibilities you can have. So what I just did here, let me do it here again. So this is minus 6 over 21. That's minus 2 over 7 because 3 goes in 6 twice. 3 goes in 21 7 times. Then this is minus 1 over 7. Then this is 5 over 7. Then this is 11 over 21. 2 over 21. Minus 10 over 21. And in the last row, you have minus 10 over 21. 2 over 21. And 11 over 21. And that is what you have. Okay, so with that, we have the last slide, which is some exercise for you, something to test your ability. So find the inverse of 1s, which is s, which is 7213. That's pretty simple. Of course, you're using the minors and cofactors method. Like I said, I'm going to do other videos where I'm going to teach maybe 2 or 3 other methods of finding inverses, and then you end up choosing what really works for you. Then and of course, in an exam, if you are told to use a particular method and you use another method because it is easier for you, you may not get all the points you need to get. So, following instruction is really important too. Then question number 2, you have a 3 by 3 matrix. 2, 3 minus 6, 1, 7, 5, 2, 2, 0. You want to find the inverse of that. Then I gave you this terrible one, a 4 by 4 matrix, which I did not do myself. Just like it said, teachers give you 1 plus 2, 3, and then they ask you to go and find 2x plus 3y. I do that a lot. So you want to try this to test yourself. Take it as a challenge. If you're able to do this, just get it across to me. You might just win a gift. Who knows? So, inverses get very complicated, right, to compute with this method as the order of the square matrices increases. Now, when we talk about the order of a square matrix, we talk about the number of rows and columns. So of course, you know that the number of rows and columns are equal. So the order is that number of row and column. So this is the order here, which we call n. The order of this square matrix is 2. The order of this one is 3 because it is 3 by 3. And the order of this one is 4. So the order of a matrix of a square matrix rather is the number of row or the number of columns the square matrix has. So as this order increases, the minus and cofactor method becomes pretty difficult. Like if you try to do what I've explained to you on this, you can see it will be very taxing. Yeah, it will be very difficult to handle, right? But you can take it as a challenge. But of course, there are all of the methods I'm going to teach you later. You discover that you don't have to sweat so much to get the determinant. So, however, like I said here, there are relatively easier methods like the Gauss-Jordan method, which you are going to learn later after you might have taken care of elementary row operations, which we should come maybe in the next 2 or 3 videos. I'm not sure now. Okay, so thank you very much for listening. Like I always say, if you have a question, you can ask in the comment section. If you want me to, if there's something you think I can do to improve what I'm doing, feel free to let me know. So you can learn, so maths can be really simple for you. Thank you so much. See you in the next video where I talk about special matrices.